Alright everybody, this is a tutorial to help you figure out how to set up, complete, and interpret monohybrid crosses by using punnett squares. Alright, let's go ahead and move on. So the purpose, we use a punnett square to determine the probability of producing an offspring with specific traits. In other words, to answer questions like, if my mom has brown hair and my dad has blonde hair, why do I have brown hair? Okay, so those are the kind of questions that we're trying to answer by using punnett squares. Alright, so here's the problem. A woman with brown hair marries a man with blonde hair. They want to know, what are the chances of having a child with blonde hair? In this example, brown hair is dominant to blonde hair. Okay, these terms you should already be familiar with: dominant and recessive, things like that. Okay, you should already be familiar with those. So here goes the problem again. A woman with brown hair marries a man with blonde hair. They want to know, what are the chances of having a child with blonde hair? In this example, brown hair is dominant to blonde hair. Alright, so let's go first, setting up the punnett square. Let me back it up. Get the right color. All right. There we go. And this is our punnett square. In order to set it up, we need to reference the actual problem. Okay? If we're going to use alleles, let's use the allele B, capital B, which is the dominant allele, lowercase b, which is the recessive allele. We said the dominant allele was brown hair color, right? So brown hair color, and the recessive allele was blonde hair color. And that comes straight from the problem on the first page. Alright, so we need to set it up. We said that the woman has brown hair. Okay? If she has brown hair, we're going to go ahead and say that she's heterozygous for her brown hair. If she's heterozygous, remember the term heterozygous. That means that she has two different alleles. She has one of each allele. So she has a dominant allele and a recessive allele in her genotype. Okay? So we take one parent and put their genotype at the top. It doesn't matter if you put mother at the top or father at the top, but just put one genotype at the top, and then you put the other genotype at the bottom. If it says that he has blonde hair, and blonde hair, remember, is represented by this recessive allele, then he has to be homozygous recessive and have two of the lowercase alleles for that trait. That's the only way that he can have this blonde hair. Alright, so when we're filling out the punnett square, we bring the allele from the top down, so capital B, and the allele from the left side over, lowercase b. Same thing for this box. Bring it down, bring it over, bring this one down, and bring it over from the left. Last box, bring it down and also over from the left. Alright, so that's our completed punnett square. Now after that, you're going to want to be able to pretty much interpret it. So we've already done the first two steps. We've set it up by putting our parents' genotypes at the top and at the left, and then we've completed it already by bringing one allele down, which is this capital B. We brought one allele over. Pardon that bell. Right? That was our process. We did the same thing in each block by bringing one down and one over. Alright? Now let's go ahead and interpret this information. So I'll quickly draw the Punnett square again so you can have it to reference. The more you do these, the quicker you can go through them. All right, so now we're interpreting it. We want to see, I think the question asks us, what was the possibility of having a child with blonde hair? All right, so let's just see. And this is dealing with complete dominance, okay? We're dealing with simple, complete dominance, which means one allele is completely dominant over the other one. Okay, we said that earlier. So we're dealing with complete dominance. So first let's look inside this chart. We have this possibility right here, which gives us a genotype, a heterozygous genotype of capital B, lowercase b. And then if you look over here, we have another one. Okay, so there's 2 out of the 4 choices. There's 2 out of these 4 squares are going to give us this genotype. So 2 out of 4 is going to be 50% with that genotype. And then you also have this other genotype right here, little b, the recessive genotype. And you have also 2 out of 4 for those as well, which will give you 50%. All right, so we'll have 50% with this genotype, 50% with that genotype. Okay? That's the genotypic ratio, all right? That's talking about the possible genotypes. And then for phenotypes, which is actually what you're going to see in the child, you have a 50% chance. If you have this genotype right here, it's going to give you what color? It'll give you brown hair, because you have this brown capital dominant allele, which is going to dominate that allele. Okay? So you'll have 50% chance of having a child with brown hair, and then you have a 50% chance of having a child with blonde hair, because it's coming from this allele right here. All right. So the answer to the question, again, the question was, what's the possibility of us having a child with blonde hair? The answer is 50%. There's a 50% chance that you would have a child with blonde hair if you had these parents, a heterozygous brown haired woman and a blonde haired man. That's how you figure out using a monohybrid cross. Thank you.